in less than 50 minutes. So the target of this video section is to give you a good know-how of MongoDB in less than 50 minutes. So after this video, using the accompanying documents, you will be able to work out the key sections of MongoDB in ease. We'll be covering most of the commonly used key topics of MongoDB. In this video section, we are going to cover these topics. The first one is the basics, where we'll be learning about the basics of MongoDB. The second one, we'll be seeing about CRUD operations on MongoDB using Mongo Booster client. We'll be seeing quite some queries in this example. Following this, we'll be learning about capped collection and TTL. These are very easy and important. Then we'll be learning about regex, full text search, and finally gridfs and aggregation. These are very easy and important. So our time starts now. So this is the PDF which is available in the resources section of this lecture. This has 11 steps. Each step has its own queries and examples. The step 1 is to learn why MongoDB is different and a simple overview about MongoDB. MongoDB is a NoSQL database. As you know, it's a leader. NoSQL primarily offers two features, that is the schemaless feature, and the second one is horizontal scalability. So these are the two things you need to remember about a NoSQL database. So MongoDB is like a Word document which is completely structureless and you can put anything into anything. Whereas the traditional databases like Oracle, MySQL or like Excel sheet, where the data will be arranged in tabular format. So this is the primary difference between MongoDB and the traditional database. There are three key things you need to remember about MongoDB. That is, it stores data in document format. The data will be in JSON format. And finally, you need to learn about the methods available in MongoDB. That is very, very important. So this diagram shows the important components of MongoDB. We have a MongoDB server. Under that, you can have many databases. Under databases, we have collections. Collection is a group of documents. So this is simple. Server has databases. Database has collections. And collections will have documents. I have connected to my local instance of MongoDB using a RoboMongo client, and you can see how the data is organized in a collection. The document will be of JSON type and it will be saved in binary format, that is called BSON. To know about JSON, please open the document which is in the resources section. Click on the sample JSON structure. There is a Wikipedia link. On clicking this, it shows a simple personal details JSON. As you can see, we have key value pairs, both are string. Then we have collection of key value pairs. So this is called object. Then we have age as a number, and then we have an array. Back to the document. To have a very quick reference about JSON, click on this link. This gives you a clear idea about a JSON data type. For instance, we have array here, we have Boolean. It supports null value, we have number values, and this is called an object in JSON. Then we have the regular string key value pairs. So this example can give you a good understanding about JSON data types. I'm in the reference documentation page of MongoDB. As you can see, the operations in MongoDB are done using methods. For instance, this find method is for finding the documents. Find and modify is for finding and modify the documents. So these methods you need to remember. Traditional databases uses SQL, whereas MongoDB uses these methods. So this is the primary thing. So always remember that MongoDB has methods. We have seen the step 1. The step 2 is to install MongoDB and its client Mongo Booster. Mongo Booster is one of the best client of MongoDB, primarily because it has two key features, that is IntelliSense, and it has code snippet support. So you can see the code snippets as well as you will be getting IntelliSense for any kind of method. So to download MongoDB, just Google for MongoDB downloads. It takes you to the MongoDB download center. Click on this. I'll be using the Windows version. Click on the MSI file. It's a straightforward installation. Once MongoDB installation is done, you need to run the MongoD.exe. This is the server process under this path, that is C program files MongoDB server 3.2 or 3.4 bin, and then you just need to run this MongoD.exe process. You can run this by double clicking, or you can run through command line. Prior to this, there is a very key step that needs to be done. That is, you need to give a data directory to MongoDB. MongoDB generally expects the data DB in this path, that is C data DB. So create this folder and then start the server process. You can double click it, or you can run through the command line. So it's cd, paste here, then MongoD.exe. So that's it. Once you are able to see this particular line waiting for connections on port 27017, this is the default port for MongoDB. It means that your server is started successfully. The next step is to install Mongo Booster. That's very easy. Search for Mongo Booster downloads. Click on the link. You'll be getting a fully functional version for 60 days. The installation is very straightforward. Download and install. Once installed, you just need to run the Mongo Booster process just by clicking here. The connection is very easy. You just need to create a connection. The default values will be auto-populated. Press test connection. It will be successful. Once that is successful, just save and connect. Now I have successfully connected to the MongoDB server. As you can see here, I have many databases pre-created on MongoDB and they are getting listed. Under databases, I'll be having collections. So click on that, you'll be shown the collections. So these are the collections. For instance, in this collection, I have around 24 documents. So this gives me the documents. The data is presented in tabular format, but the true format is on JSON format. So this is the format in which the data will be presented to you, but Mongo Booster is giving you options to view the data either in tree format or in tabular format or in the true JSON format. Now we are in step 3. Step 3 is to create database, create collection. Just remember the architecture: server has databases and database has collections. Let me create the database first. Right click, create database. The database name is demo. So database is successfully created without collections. Now to create collection, right click, create collection. So let me give the name here. I think it is user profile. Yes. So user profile. Okay. Collection is successfully created but without documents. Open shell. Let me create collection through command line now. Pasted the code. Let me make it as a user profile. Yes. On executing this, you can see the collection is created through command line also. Refresh. So we got two collections: user profile, which is created through wizard. The second one is user profile X. I'm going to drop this one. Drop collection. On running this, the collection got dropped. You can see true printed here. The next step is to insert documents into this collection. For this, we'll be moving to step 4. There are two key things to note: are document with different structures in same collection. Every document will have a default underscore ID. So let's see the first one. For instance, here we'll be having two user profiles, one with ID, name, age, income, sex, nationality, language, additional info, etc. The second user profile will be different, where we'll be having user ID, logged in, last login, location type, etc. So different structures. This is a sample data which we are going to insert. This is the first one and this is the second one. So two different types of documents are going to be there in the collection. So that's important. Step 5 is to do a basic CRUD operation in MongoDB, insertion and multiple insert in single query. Sample data. So we are going to insert the first sample data. Let me select from the JS file which I have. Now I have to paste this on the window. Right click here, view. So it's an empty collection as we know that. I'm going to paste here. Pasted. As you can see here, we are going to insert in user profile. The query is very clear. If you keep the cursor over there, you'll be able to see the method, syntax, everything. Now let me show you the code snippet, user profile dot insert. As you can see here, you can see the code snippet as well as the method definition. The code snippet is easy, you can easily understand from it, and the method definition is below that. So that's the coolest feature of Mongo Booster. Now I'm going to run this one on running. We must see 2 documents created. Yes, 2 got created. Right click, view. So these are the 2 documents created in JSON view. Now back to table view. Now I'm going to insert the sample data too. So let me copy from the JS file. Copy it. Have pasted it. And I'm going to execute this one. I'm running this. New documents are created. So totally we have 5 documents. Right click, view documents. So we have 5 documents. As you can see here, the documents have completely different structure. That's the beauty of MongoDB. We can have different structured documents in the same collection. So this is what is the first point we mentioned, documents with different structures in the same collection. The second one is every document will have a default field ID. So this field underscore ID is created by default. It is auto-generated. It is unique. There is a bug with Mongo Booster that this ID column, which I haven't mentioned, is shown there. But if you check with RoboMongo software, there is no ID column. So it's a bug with Mongo Booster. So ignore that. So just focus on this one. This ID column, underscore ID column is auto-generated. So it's auto-generated, unique, it is indexed and can be replaced. So now to the step 5b, that is CRUD operation in MongoDB, finding documents. I have the code here. Let me copy paste to Mongo Booster. Right click, view documents. I'm going to paste it in a new window. So pasted. The first one is a find method. So under collection methods documentation, you'll be able to see the find method. db.collection.find, and we have the query and the projection as a parameter to the find method. So let's do that. Field value. So I'm just giving a empty find. So it is going to list all the elements. So we got it. The next one is nationality. We are going to select as Australia. Let me execute this one. So we must see the record only with Australia. Yes, the single record with the nationality is Australia is listed here. The next one, we are going to use the age field. For instance, here age is greater than 30. To know about these operators, please visit query and projection operator section in the documentation. Click query selectors. You'll be able to see the operators equal to, greater than, equal to, less than, equal to, not equal to, and all. So we are going to use greater than operator here. and in the next one we'll be using less than operator. Let me run this one. So we got age greater than 30 listed here. The next one is to find documents with age less than 30. So we got a single document with age less than 30. Here it is 26. The next one is the AND operator. We have two conditions. The primary key to note is the square brace. So we'll be having multiple conditions within the square brace. The condition number 1 is the age has to be less than 35, and the condition number 2 is age has to be greater than 20. To know more about AND and OR operator, visit the query and projection operator sections in the documentation. Under this we have logical operator. Yes, we have here. You can get the details of AND, OR and other logical operators here. Now back to our code. On running this, we must see documents with age between 20 to 35. Yes, we have two documents with age between 20 to 35. Next, it's the same for OR operator, which is going to give us a lot of documents because the conditions are same. It is similar to AND operator, but in the opposite way. On executing this, so these are the documents with OR condition satisfied here. The next in our list is count, limit the number of documents, which is going to skip the number of documents, and sort. We have 1 for ascending and -1 for descending. So we are going to see this. The first one is count. On running this, it's going to give the count of documents. Yes, we got 6. The next one, we are going to limit the number of documents to 2. So we must get only 2 documents. Yes, we got only 2. Following this, we have skip operator, which is going to skip the top 2. So we'll get 4. The other 2 documents are skipped. The next one is sort method. We are going to use the ID field, which is going to do a -1, that is descending order of this ID field. Let me execute this one. Run. Yes, we got the ID field in the descending order 4, 3, 2, 1. So if you want to see the definition of sort, you just keep the cursor over there. You'll be able to see the description of it. We have seen finding documents. The next is 5C, that is update and deleting documents. So we are going to use the update method. We are going to update the location US to location as United States of America. To Mongo Booster, right click, update documents. So we got the query here, update. You can see the update syntax here. Then we have a set operator. Then we have option fields, multi. Multi means it will update multiple documents. Currently it is false. These are all option fields. The next we have upsert. Upsert means it will find for the document. If it is not there, it is going to insert. It is also set to false. So this is optional. We can totally take it off. So let me take the query from the JS file. I have copied it. I'm going to paste here. Yes, done. On executing this, we must see a single document updated with location US to USA. Done. So one matched, one document got updated. Let me view the documents to see the changes. View. Yes, as you can see here, one document has got updated. That is because we have set multi as false. The default is multi false. It's not like our traditional databases. So if you give multi as true, the option as true, it is going to update multiple documents. So let me execute this. On running this, the documents got updated. Let us view the documents. Right click, view documents. As you can see here, the documents have updated. The next one in our list is to do a remove. Let me copy this code here to Mongo Booster. On executing this, the first 2 documents with user ID 01, 001, 002 will get deleted, so removed successfully. Right click, view documents, so the documents are gone. So this is how remove works. It's very simple. You just need to call the remove method. So we have finished updating and deleting documents. So we have finished the basics, we have finished the simple CRUD operation. The next is capital collection. Capital collection is very easy. The only main difference between capital collection and the other collections are we have a size limitation in capital collection. For instance, we will be setting the maximum size as 10 here. So it can hold only 10 documents at a time. So all other documents will be ejected out. So let me copy this query, paste it here, done. Cap is true, size is limited, 50 KB. On executing this, we must see a new collection by name, log capped. Let me do a refresh. So we got the log capped collection without any records. Now I'm going to insert the test data into that. Now I'm going to insert the demo data into log capped collection. Let me copy from the JS file. Now I'm going to insert log data into this. As you can see here, we have log 1, log 2, log 3, log 12. So this is the demo data we are going to use, but the max is 10. So 2 of this will get ejected. I mean the log 1 and log 2 will get ejected. So we must have only the data from log 3 till log 12. Run, success. Let me do a refresh first. Yeah, we got only 10 records as you can see here. That's because we have capped the collection to 10. Let me view it. Yeah. So as I mentioned earlier, we have only 10 records, that's starting from 3. We are going to see about indexing. Indexing is one of the primary part of database management because it fastens your search query. In MongoDB by default, it creates an index on every document on the ID field. So in this demo section, we are going to learn how search works before and after indexing. So for that, we'll be using explain method. So this is the field I have been mentioning. Default index is created in the ID field. Let me copy the query. As you can see, I'm searching for income with around 6 million. On executing this, we'll be able to see the result in JSON format where we'll be getting the total number of documents examined. That's here. Currently, we have 4 documents and all the 4 documents are examined to find a document with this income matching. So let us create an index on the income field and see how the search works out. So we are going to create an index on the income field. The syntax is very easy. That's create index method is called with the field. On running this, yes, the index has been successfully created. Number of indexes after is 2 and before is 1. And you can use view indexes to see the indexes in the collection. Get indexes. Now you can see here we have 2 indexes. So now let us see the execution statistics. On clicking run, we must see the documents examined must be less. So total docs examined is just 1. Previously it was 4. So that's the power of index. To drop index, it is very easy. You just need to call the drop index method on the particular field. That will drop the index. Now to the step 8, that is a TTL collection. TTL collection stands for time to live collection, where the data will be kept only for the specified seconds. Note that it is seconds, not milliseconds. So the documents will be automatically deleted after a particular specified second. So in our case, demo TTL is a collection name. To create a TTL index, it is very easy. You just need to create an index specifying that it will expire after particular second. So log data is a field, demo TTL is a collection name. So create collection is demo TTL. Now it's created successfully. Right click, indexes, add index. So add field. Field name is log underscore data. Okay. Expire after. Just see the field. We have expire after. I'm specifying. I'm going to preview it. On clicking preview, you'll be able to see the query here. So it has created a create index on this field, which is going to expire after seconds 10. So it is similar to our query. On running this, we must see expire seconds. I have to select completely. On running this, we must see the index is created successfully. So the number of indexes after is 2 and before is 1. Now right click, indexes, view indexes. So as you can see here, we have 2 indexes now. The expire after seconds is 10 for a particular index. The next step is to insert the test data. Now we don't have any data here. As you can see here, I'm going to just insert date on the log field. Let me copy this. So log data will have only date. I'm going to run this multiple times. 1, 2, 3, 4. So 4 times it got executed. You must see 4 documents here. View. So we got 4 documents inserted at different times. As you can see here, I'll keep on executing this. So after 10 seconds, the data must go off. Yes. Now there are no records in the collection. So this is how TTL index works. So just remember the syntax. Now to the next step, that is step 9, text search. Full text search. Full text search is very important in MongoDB because it is schemaless. It's very easy to do a full text search. You just need to create a text index on a field. As you can see in the documentation here. So this is a documentation page for text search. MongoDB supports query operations that perform text search on string content. MongoDB uses text index and the text operator. So this is important. So we have to create a text index and we have to use a text operator. So this is the syntax for the text operator, which will be performing the search. We'll be giving the search string first, then we'll be specifying the language, then we'll be specifying whether it's case sensitive or not, and finally we'll be specifying whether it is diacritic sensitive or not. So this is the syntax for text operator. Prior to that, do remember that we need to create the text index. So let me do the first step, that is to create a text index. Let me copy from the JS file, copied it. So demos text search is the collection name, copied it, pasted here. So we don't have an index. So let me create a collection for this. So demo text search. So the collection is created. Now I'm going to create an index on the message field. So indexes before and after is 2 and 1. Indexes, I'm going to view indexes. As you can see, we have 2 indexes. One is of type text. Now I'm going to insert text data value into full text search. So let me copy it from the JS file, paste it on Mongo Booster, and then run it. So now we must see around 11 records here. Let me do a refresh. We have 11 records. 11 documents. If you see the document, it's very easy. It has messages, good coffee, cures fat liver, good coffee, best Mongol. So it's a simple document. Search in full text. The first one is to search for message with good, easy. So it will be search both with good and easy. Let me paste it. On running this query, we must get messages with both good and easy. But currently we won't find because it's not a text search. It's a plain find query. So it won't find anything. So let us give it same thing with text search now. Pasted it. As you can see, I have used the text operator. Previously I haven't used it. And then I have given the search operator. On running this, we must see the documents with both good and easy. Let me expand this one. So easy. So we have documents matching easy and good. Now I'm going to ignore fatty. On executing this, we must get results without fatty. Yes. So the document with fatty text is not selected. So let me show it again. In our previous execution, we got the document with fatty liver is mentioned, but currently, since we are ignoring it, the particular document with fatty text is ignored. Next one, I'm going to search a complete text is also here. On executing this, we must get an exact document. So which has the exact text. Now the interesting one, that is, I'm going to search for goodness. It will be listing the documents with good also. That's the power of text search. Selected, run. So you can see documents with good text also. So that is the intelligence of full text search. Now to the next one, where we are going to search for easiness. So it will list the document with words easy also. Let me run this one. As you can see, MongoDB queries are easy. So this document got listed after we searched for easiness. Similarly, we can search for happy. We will get documents with happy as well as happiness. As you can see in the result, we have document with happy as well as happiness. Now I'm going to search the word the easy. The word the will be ignored. Let me search it. As you can see, there are no the in the document and it is ignored. So the common words will be ignored. The next one is very interesting and important. Please note that every document search will have a text score. You can also manually rate a document, or by default it will be given a text score. Remember that every document has a text score. So now we are going to see what the text score for every document. I am going to search for coffee. So as you can see here, the search results have score mentioned over here. So every document is having a text score, and note that the text score is based on its own algorithm. For example, if you take the first document, we have coffee repeated many times, so its text score is higher for this particular keyword coffee. So it's easily understandable. This is how text search works. So 3 things to remember. For text search, you must create a text index. Number 2, you need to use text operator and search operator. And number 3 is every document will be given a text score by default. You can also edit the text score manually. Now let us move to the next topic. We are going to see about regex. Regex is very important because we have different formats of data, and regex eases our work. This is the documentation page for regex, and we'll be using the regex operator. The good thing about regex is that it is Perl compatible. PCRE or Perl compatible regex are very famous. The syntax to use regex operator is shown below. As you can see here in the leftmost, we have a field name, then we have a regex operator followed by pattern, and then we have options operator with different options. This is a sample data we are going to use for our demo session. It is very simple and it has only name field. Now let me copy the data to Mongo Booster. Pasted. On executing, we must get around 13 records. Refresh. Yes, we have the persons collection with 13 documents. So we have Rick David, Elizabeth David, David is in uppercase, and David Warner, David, John David 1, Paula David, Davidson, David King, first David, fifth David, Siju David, and then the names Arun, Karun, Ahmed without David in them. Now let us start with the regex queries. So now let us start with the first one in regex queries. Let me copy this to the Mongo Booster. On executing this, we must see names with both David and Arun in them. So we have Rick David, Davidson, David, all those. And then for Arun, we have Arun and Karun. Karun is included because Arun is there. Now to the next one. Regex search with all David in caps and with options as I. If you see the documentation, I is for case insensitivity. So we have case insensitive search here. So let me copy this one and execute here. And on executing, we must see David names with David in both small as well as in capital letters. So that's done. The next pattern is similar to that of the first one, which has the same function as that of the first query what we executed. And similarly, the next one is for ignoring the case. Let me execute this. The result will be similar to the first one. So we got the similar result to that of first one. And for case ignore search, so we have both cases listed here. Now this is a simple query where we are just going to search for David in caps. So let me execute this. On executing this, we must see only two documents with David in caps. Now this is interesting. We'll be searching for starting with. So here we are going to search for starts with 1. So we must get first David. Yes, we got the same result as we expected. Result is first David. The next one is we are going to search for the term son star. So we'll be getting Davidson here and case is ignored. As you can see here, we have Davidson, David King. This record will be listed in the result. Running this, yes, as we expected, we got Davidson, David King. So that's because of this pattern. To the next one, where the name is going to end with run, we'll be using the dollar symbol in that selection, and then on executing, we must see Arun and Karun. Yes, as we expected, we got two records with ending with run dollar. Next is we are going to search names with digits in them. Let me select this. On execution, we must see three documents. Yes, John David 1, where we have number, first David and then fifth David. So this is how regex works. With this, we have seen about the basics of regex operations in MongoDB. You need to refer to the Perl regex manual and MongoDB regex manual. GridFS is very important, as you know that it allows us to save as documents with sizes more than 16 MB, which is the BSON limit. This is the GridFS documentation page. GridFS is a specification for storing and retrieving files that exceed the BSON document size limit of 16 MB. So this is the definition for GridFS. Instead of storing a file in a single document, GridFS divides into parts and chunks and stores each chunk as a separate document. GridFS uses two collections to store files. One collection stores in file chunks and others in file metadata. So this picture can give you a good idea about GridFS. As I said earlier, always remember that there is a 16 MB file limit for the bzone file. So using MongoDB, we'll be using MongoFiles command. We'll be creating a bucket which will have two collections for FS chunks, which will save file chunks, and a FS files collection which saves the metadata about the file chunks created above. So this is very easy. Let us see a simple demo. We'll be using a simple demo using Mongo Booster. We'll be using GridFS bucket, and it will create two collections, FS chunks and FS files. So first step is to right click here, create GridFS bucket. On clicking this, demo underscore GridFS. So the name of the bucket is demo underscore GridFS bucket. And on clicking OK, we must see a new bucket here with a symbol of save icon. The next step is to add files to that. Right click, add files. So this is the image file I have selected. There are two options, with full path, without full path. I'll be selecting without full path. On clicking this, the file will get uploaded and the file got saved in the bucket. And on right clicking, on clicking view documents, we must see file chunks, around 6 we have. To view the image, double click here. It shows the image uploaded. Note that this is in Mongo Booster, not in image viewer. Now we have seen a simple demo about GridFS. Now let us move to the next topic, that is aggregation. This is one of the important topic in MongoDB, but it is very easy to understand. In aggregation, we have three types of aggregation. Aggregation pipeline. This is a widely used, commonly used one. The next one is MapReduce. Aggregation pipeline replaces MapReduce, and then we have single purpose aggregation operations. Under single purpose aggregation operations, we have count, distinct and group methods. Count is for counting, distinct is for getting distinct records. Group is not suggested to use. So let us see more about aggregation pipeline. For aggregation pipeline, we have stages, expressions and accumulators. As you can understand from the name itself, stages process the data in stages, so match operator and group operator are used, whereas for expressions we have string arithmetic expressions, and for accumulators we have sum, average. To easily understand about MongoDB aggregation, Google for MongoDB aggregation, click on the link aggregation under MongoDB manual, click aggregation pipeline. A very good diagram explaining aggregation is provided. As you can see here, we have different order details. So we have aggregate method, and we have two stages here, that is a match stage and the group stage. We have different order details here, each one having a custom ID. A match operator is applied, and customers with status A are matched here. All are having status A. The last one is having status D, that is ignored. Then a group operator is applied here. The group operator groups the records with similar customer ID, and it shows the total of the orders in status A. This clearly explains how aggregate works. So let us start with the user profile count. We are going to do a count in the user profile collection. So we have 4 records here, view documents. Now we have 4. Count has to give us 4. We got 4. Now db.userprofile.distinct. I'm going to take off this slice, it's not required. Distinct on a particular field name. So let me do a find to see the field name. We're going to do a distinct in the age field. So here it's age. On running this, we must see the distinct age values. So this gives us a distinct age values. So we have 35, 26, 30. So those are distinct. Now to the third query, where we are going to use the aggregate method. We are going to match based on the income greater than 4 million. Record from here. Let me copy the query from here, paste it on MongoBooster. On running this, we must see records with income greater than 400,000. So we got 5 and 7. So both have greater than $4 million income. Now to the next one, where we are going to use group operator. We are going to count the total users using the sum. On running this, so we must get 4. We got 4 because our greater than value is 40,000 only. So we got 4 total users. Now to the next one, where we are going to do a sum based on the income. So income field is used. This will give the sum of persons whose income is greater than $4 million. So we got $13 million. Match first. As you can see, we have 5 million and 7 million. So the result is 13 million. The sum operator is used on the income field. So dollar income is a field. So that is the key point to note. We have used greater than. So we got 13 million. Now let me use less than here. On running this, the result is 680,000. Let me do a match on this to demonstrate. So we have two incomes, 290 plus 390, so it adds up to 680. Do always remember to see and understand the diagram in the documentation. It gives you a clear idea about how aggregation works. So we have covered all the basic topics. The basics is done, the simple CRUD operations is done, capital collection we have seen, TTL we have seen, regex, full text search, grid FS and aggregation. We have covered all the topics. So this video section is aimed to just give you an intro about these topics.